Okay. Hello, everyone. Welcome to the Monday office hour. I believe we're now in week 7 of the 8 weeks of Unit 1 of the Introduction to Data Science module. As per usual, if you have any questions for me, you can share those in the live chat. And I'll be going over some questions from the discussion board. I answered a few questions yesterday, but I see there are some questions from yesterday, and there were also some questions I didn't answer, anticipating that I would rather go over those during office hours. So I'll just open up some of these and then try and locate these ones that I skipped. I'll review this exercise as well. Maybe I'll do that first, since that will be relatively quick. Okay, so I think I have all the questions that I'm going to try to address, maybe plus a few actually. And the first thing I want to go over is this exercise I posed from the statistics lecture. There were 3 scenarios I presented, and I asked if each one would be an example of a question we would want to answer using hypothesis testing or parameter estimation. And so far, the questions or the answers have been split between different opinions, but most of the opinions have been presented without arguments. Saying, question 1 and 2 are hypothesis testing. Question 3 is parameter estimation. This one gives some reasoning explaining what parameter estimation and hypothesis testing are. This one gives some reasoning. And I think this answer is probably the best answer so far. So they identified that the first 2 questions, is the current temperature similar to the average temperature for the day or season? And how does the change in stock price compare to the volatility of the stock, as questions we would answer using hypothesis testing? And essentially, the reason is because we're making a comparison of some observation to a assumed normality, to some assumed state of affairs. So, based on previous temperatures for this day or this season, we have some idea of what today's temperature should be in some sense, what a typical temperature might be for the day. So we start out with some assumed value for what the temperature ought to be, and then we compare what the actual temperature is to that assumed normal. And then we determine whether or not there is a significant difference. Is today significantly different in temperature from the other, rest of the days this season, or from this day in preceding years? In this question, we're comparing a change in stock price to the volatility of a stock. So, historically, some stock goes up and down day to day, more or less at random. Of course, there are things that cause it, but they are numerous and difficult to predict. And we don't necessarily understand all the relationships. So we say, we'll just say this is, from my perspective, basically random. And those random changes, we can calculate the variance of those, and that gives us the volatility of the stock. And then we can look at a change in stock price, say today from yesterday. And if we assume, that the kind of change we'd expect to see is equal to the square root of the volatility, or perhaps just the volatility itself. I can't remember if volatility matches variance or standard deviation. We would compare that stock price to the volatility to determine whether or not that change in stock price is significant. Meanwhile, this student said that for the last question, we just want to estimate the average salary. Here we're just asking, what is the average salary of a data scientist in Brazil? So this would be an example of parameter estimation, where we essentially are saying I have no idea what to expect here. I have no assumptions, but I would like to get some probabilistic measure of the upper and lower bound for the going rate for a data scientist in Brazil. So I go out and I collect some salary data from Brazilian data scientists, and I find that with 95% confidence, the true salary lies between $60,000 a year and $100,000 a year, or something like that. I don't know. So with that out of the way, let's turn to some student questions. So this is not really, say, an answer. This is an update to a question. So I'm going to add this as an update. So this student is having difficulty with DW question 4, particularly understanding what standard deviation we should be calculating. This is correct. This is not the correct understanding. The relative proportion of opioids, as stated in the instructions, is the proportion of opioids prescribed by a particular practice minus the proportion of all prescriptions which are for opioids, regardless of practice. In other words, say in our scripts data, we have a practice with code 8B09S3. The relative proportion of opioids prescribed by this practice would be given by scripts practice equals this thing here. opioid mean minus Scripps opioid dot mean, where we assume our Scripps table has a opioid column that flags which prescriptions are for opioids. Taking a mean of a Boolean column, i.e. 0, has the effect of calculating a proportion. To answer what's we should be calculating the standard deviation of, we need to understand what, from the perspective of our question, what is a sample and what is the population? We're interested in detecting whether the opioid prescription rate of a particular practice is significantly different from other practices. Therefore, in our hypothesis testing framework, our null hypothesis, i.e. the assumed true parameters, mu and sigma, are given by, are estimated by will be set by the entire prescription data. That means mu equals Scripps opioid mean, which means the relative proportion of opioids described above is the numerator of our z-score, while sigma is the standard deviation of this same column, i.e. Scripps opioid.std. Meanwhile, each practice is essentially a separate sample from this population. Some samples will be significantly different, high z-scores, from the population, while others won't be. It's not only you. There has been 3 or 4 people watching, so there's at least 1 or 2 others watching as well. We have a question here about someone's mul method not working correctly. And I'm not sure exactly whether or not this syntax is allowed. I'm going to quickly check that. Okay, yeah, the problem is that this syntax is not valid. So to check whether an object is an instance of multiple possible superclasses, we don't write is instance X or var. Let me just quickly check that var is not a protected keyword. Yeah, cool. Int or float, but instead write is instance var int float. You can check yourself that is instance 5.4 int or float returns false, while is instance 5.4 int float returns true. So if they are using a count, this count will obviously be an integer. All counts are integers. Integers are the counting numbers. So that passes through here just fine. But this or is not understood. So 1 over a count will return a float, which means that this test will fail. Since count will always be an integer, is instance count int or float will return true, which means your true div method will work, but 1 over count is a float, so is instance 1 over count int or float will return false due to the bad syntax. So your mul method will fail. Often debugging is basically as simple as like breaking apart your code and checking that things like your conditional statements actually do what you expect them to do with some test cases. So this is pretty close. I would not worry about this. Note that the grader only marks an answer wrong if the answer is off by more than, let's see here. I think it's 5%, but it could be less. It's 1%. No, 5%. your z-score is off only by, what is this, like, tenth of a percent? 11.70, so 0.01 divided by 11. 1/10, yeah, a tenth of a percent. However, obviously, a substantial portion of your answers are off by substantially more, or have the wrong practice name associated with them. Since the practice name portion of the answer is essentially pass-fail, i.e. we need an exact match, my first suspicion is that let's see, there's some ambiguity here for what name we use. I think it's just another one of these cases where we say use the alphabetically first name. Note some practice codes will correspond with multiple names. In that case, use the first match when sorting alphabetically. Perhaps you've neglected to select the alphabetically first practice name for practice codes which are duplicated. Note that this is different from earlier questions where we asked you to remove duplicate practice codes by selecting practices with the alphabetically first postal code, not name. Your z-score calculation, you describe correctly. So my next thing to check would be that you are returning, what is it? The count of prescriptions, not the count of how many opioid prescriptions there are. So let's quickly read in the scripts data. And the practice data, because I don't remember which practice corresponds with this national enhanced service. So practices, okay, that wasn't what I wanted. There we go. So practices name equals national enhanced service. There we go. Y01 852. So yeah, there's 7 prescriptions, not 7 opioid prescriptions. The count of prescriptions and not the count of opioid prescriptions for each practice. Often mistakes resulting in low grades can be traced back to missing details in the instructions, not only mistakes in calculations. So it looks like someone else has answered that question already. Let's see here. This seems like a low answer. If we want a total, then we should perform a sum, not a count. Yeah, I don't know what's more to be said here. Count will give us the number of entries in this column for each group, not the sum total. Okay. So question 6, rare scripts. We have to identify which BNF codes are rare. P, SP stats norm CDF, 0.1. No, this is completely the wrong way to calculate P. The issue most likely lies with how you are calculating P, which will influence every subsequent step. As per the instructions, P represents the probability of a prescription having a particular BNF code if the BNF code was randomly chosen from the unique options in the beneficiary data. In other words, if I put every unique BNF code, i.e. scripts BNF code dot unique into a hat, and I picked one out randomly, what is the probability that I select a particular BNF code? If there are n BNF codes, then there is a 1 over n probability that I select a particular one. In other words, P equals 1 divided by scripts BNF code dot n unique. So we just count up how many unique BNF codes we have, and there's a 1 in however many that is chance of picking a particular one. And if, doctors prescribed treatments by just uniformly randomly selecting among all the available possibilities, then this would be the probability that that any particular BNF name would be chosen. Okay, I think this was maybe the last holdover from when I was answering questions yesterday that I wanted to answer during the office hours. Yep, and I remember this being really confusing. Okay, so they're asking about question 4 in the PW mini project. So they have these two objects that pass these assertions, so they're at least that long. To get the max item per BNF name per postal code, I have done the below. Sorted items. So I don't know what post is. Total items by post. Post. So I would expect this would give you just an integer or perhaps a list of integers. Key, lambda, k, BNF name, but it's not the case. Apparently, this also contains BNF names. So this is, I suppose, the regrouped version of this to be just postcodes, group by postcode. So this gives us maybe a bunch of BNF name item total dictionaries, and we're sorting that list of dictionaries by the BNF name. So we get the alphabetically first BNF name, and then the alphabetically second one, etc. Using the 100 keys from postal totals, already sorted in alphabetical order, I iterate through the lists returned by sorted, looking for the BNF name with the highest items. So max items by post, name 0 for name in this sorted dictionary of postal totals. So that will give us back all the postal names, all the postcodes. So this is a dictionary keyed by postcodes. For post in that dictionary, fine. I equals 0, sorted items, sorted total items by post, post. Okay, so this is just the thing up here. While I is less than the list of items, if sorted items I, items is not equal to max items post, then we update the max items to be the max of either our sorted items or the max item. So why not only have this trigger when this is greater than this? And then we don't need to do this max even. Nonetheless, at each step we increment I. First, a few stylistic comments. There is no reason to use a while loop, and we could just iterate for element in sorted items. Then we could use element rather than, or for item in sorted items, right? Sorted items I. This would help avoid the possibility of any infinite loops based on for getting to based on not incrementing I correctly. And is much more readable. Also, rather than performing a max every time sorted items I'll write it as I would write it. So items is not equal to max items post. Why not simply update max items post when items is greater than max items post. As your code is currently written, if I have a two BNF names with the same item total, it's possible that the alphabetically later item will be used for max items post. Because well, what's this max gonna do? I mean, it's just not clear what the output of max, for example, like 300A, 300B should be. But here it's not even like clear. It looks like this would just be an item count, and so would this. But these max item by post elements would hopefully be tuples. So after I iterate through the above, through the sorted total items by post to find the first BNF name with items equal to max items post for that postal code. Oh, okay. Sure. This would save us some computation. Let's see here. I'm gonna check some notes about the answers. Postal totals. Okay, this number is too small. To directly answer your why your solution is my final stylistic comment is we don't have to first compute the max item total for each postal code and then iterate over sorted items to find the appropriate BNF name. We could combine these into a single step by instead simply storing item in accordance with my previous note in max items post instead of item items. So to directly answer why your solution is getting a is coming out wrong, it appears that your item totals are not item totals, but are rather the maximum number of items associated with an individual prescription in each postal code. Look back to your computations for total items by BNF post and make sure you are summing up all the items associated with each postcode BNF name pair, not just selecting the prescription with the maximum number of items prescribed. Okay, I think that's basically the last question I have on my plate. We have 10 minutes left, so if anyone watching has live questions, I welcome you, of course, always to ask them whenever you want, but particularly now, I don't have anything else to answer on the discussion board, so either you ask me questions or I do other stuff for the remaining 10 minutes. In the meantime, I guess I'll download the previous office hours and get those uploaded to the Google Drive. So we currently have the office hours up through 16. Yep. So we need 17 through 20. Well, this download is remarkably slow. Can we discuss hashing and hash tables for this cohort? I already did. So I've discussed it a couple of times in the office hours, but also just in the data structures notebook, there's a description of how hashing works. In the explanation of sets and dictionaries as unordered data structures. And then I also mentioned several times this excellent book, Problem Solving with Algorithms and Data Structures Using Python. So you can simply Google this and come to this book. And chapter 5 about sorting and searching has a whole section on hashing. So if you really want a lot of more material on hashing, I'd recommend reading that. But already there's like a section that describes how hashing works and what the idea is. It doesn't go into details about, for instance, hash collisions or anything like that. But you don't really need to know that level of detail to understand why things like sets and dictionaries are useful. So I'd recommend going back to the lecture on sets and reviewing that material. And if you really want to get deep into it, reading this book, or this chapter of this book anyway. Okay, a summary of hashing is I have some function that I've designed with clever mathematics to give me hopefully more or less unique output for whatever set of inputs I expect to handle. And those outputs are essentially memory addresses. And I decide how I'm going. Well, that's actually separate. That's a hash table, right? Hashing is just like I cleverly design a mathematical function such that it gives me more or less unique outputs for each input that I expect to handle. That's hashing. Hash tables are, I use these unique outputs to decide where the input will be stored in memory. The inputs are now like elements of a data structure, and I apportion those elements into memory based on the output of the hash function. That's all there is to it. So that brings us to the end of the hour. So I'm going to get these videos uploaded to the Google Drive so we stay up to date on office hour video downloads. And I'll be back tomorrow for another office hour. Have a good rest of your day.